Okay, so this is Rishmal Farman and I'll be explaining our codes. First one is sequential code. In the start, we are including header files, and then we are like defining our simulation parameters. The commands are being done against each parameter, and this is basically a function which we'll be using to visualize our output for better understanding. Let's, without delay, move towards the main code. In this third, we are basically doing the memory allocation. These arrays store our temperature values at current and next time steps. And if we move forward, we are basically initializing our temperature distribution with sinusoidal pattern in here. And then if we move forward, this is where our main computation is happening. This basically implements the finite difference method, where each row of the temperature depends on its current value and its neighbors as well. Okay, and now we'll be moving here as well. The visualization is being happening. The performance metrics for Amdahl's law, we have explained this law in our report already. If we move towards the OpenMP implementation, there is basically an additional header omp.h. We are using 4 processors, and this is the place where we'll be applying pragma omp parallel for, because we are using a for loop, and a reduction is basically double abs temp. This is a variable which is going through critical section problem. That is why we're using reduction in here. And in here we are using pragma omp parallel for, because this is above a for loop, and here as well. Lastly, we'll be moving towards our MPI implementation, and in our MPI implementation we start with a rank and size implementation, as we'll be using these two variables in the later code. And here we are dividing our domain among two processes. And lastly, there is processes exchanging data through these two line of codes. Yeah, that's all from the code side. And now we'll be explaining the comparisons in our report. Thank you.